Alright, so the last section of this one deals with mostly looking at the graphs of these radical functions and square root and other radicals and what they kind of look like. Okay, and so a even square root, so like, or an even root, so like a square root of x. What it looks like graphically is, if we're talking about the plus and the minus side, okay, it looks like a parabola that's kind of been tipped over. Okay, that's what it would look like. Now you've got to make sure you do the plus or minus. Now if you just type into your calculator, or if you just graph the positive side of it, what you're going to have is you're going to have it look just like that. Okay, that would be just the positive, and then the negative would be the bottom half. Okay, and that's true for all even. That's true for all even radicals, or even roots. Now if we have an odd root, so if we want to take the cube root of x, if you were to graph that, you'll notice you don't need the plus or minus part on it. What it'll look like is it'll look like that. It'll start and go the entire way. Okay, and so that would be your cube root, or fifth root, or sixth, or seventh root, or ninth root, or 11th root. The odd roots will look something like this. It can change if you have different things thrown in there, but most of them will look like this is what would be called the parent function. Okay. So again, graphing, the first one is called our parent function. Okay, it's the original. It's the basis of all of them. And then from here we do everything, shifting left, right, up, down, inverting, etc., etc. So the first, remember, if it's inside and it's being attached directly to the x, okay, you move the direction that's opposite that sign. So since it's a negative, that means we would move it right. Okay, it would be moved right 5. On the inside, it's a plus 7. So plus means left, because remember, lefties are better than righties. Okay, so that means we would move it left 7. Now the last one, we've got a negative out front, which means that we invert it. Okay, so it's inverted. Now if you have something that's being added outside the radical, so if I were to say on this top one plus 8, okay, but it's not under the radical, as you see it's outside of it, this is the up or down. Okay, so this would be moved up 8. Now if we looked at this one, I said, minus 6, this would be down 6. So if you add or subtract anything outside of the radical, that is the shifting up and down. If it's added or subtracted inside the radical, that's the left or right. Okay, it's just like when we were dealing with the square roots and everything. So graphing these, so this first one, that would be a shift up 4. And the next one would be a shift down 8. Okay. And now here, if you want to look, you can type in all these into your graphing calculator and see how they change. And you'll be able to see, oh, this is what this one looks like graphing. This one, what this one looks like. The first one will look something like this. That's pretty bad, but it looks something like that. The next one, if we're just doing the positive, would look like this. That would be that one. The fifth root would look something like this. Oh, actually it'd look something like that. That'd be the fifth root. And then the 10th root would be like that. And so that's what it would look like. And it's just something you might want to investigate with your calculator and just see how it works. And this shifting up, down, left, right works with all of these. So the shifting up, down, left, right work with all of them. Okay. And so as you see, the green ones kind of look the same and the red ones kind of look the same when you graph them. Okay. Alright, so to find the time of an object falling, blah, 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 to Earth, we use a certain equation, or we use, for the height, we use the formula t, or the time it takes for it to fall at a given height, is based on this formula, square root of 2h over g. How high must an object be for for it to fall in 7 seconds. So what you would do is you can use your graphing calculator with these. Okay. Gravity is usually about, if we're in feet, it'd be 32. Okay, 32 feet per second. And feet per second squared. And so what you'll do is that you can type into your calculator, you can go y is equal to the square root of 2h all over 32. Okay. And when you plug that in, okay, you'll be able to see your curve. And then what you're going to be looking for is you'll be going under calc, which is second trace. You see under calc, it says value. Okay, you're going to click on value on your calculator, and then it comes up on the screen. It says underneath, it'll say x equals, and it'll be like flashing. Plug in 7, push enter, and it should give you your number. Okay, so as you see here, this is another way of doing it. Okay, plug in the original function in for the f of x. For your next one, plug in y equals 7 in your second function. When you graph them, you'll see they intersect. Make sure it's in the window. Otherwise, you might have to blow out your window. You go second trace, and you move down to the fifth one, which is intersect. So this is another one. You could either do the value or intersect. Either one will work. Select the two functions on your calculator, and then push enter, enter, and it should tell you where they intersect, which will occur at approximately that right there. Okay. And so that means that you're about 240.345 feet in the air. You will travel that far in 7 seconds. Okay, if you were to drop something. So this is very much calculator. You're going to be using your calculator for these. So what you're going to do for these is the first two describe. So is it moving up, down, left, right? Is it inverted? Is it not? Up, down, left, right. Describe the functions for the first two. Okay, and then next one, use your graphing calculator and solve, find where they intersect. Okay, so find where they're equal. You're going to plug the first one in for y equals for the first one, and then the second one you're going to go y equals 2. And you want to see where they intersect. Okay. And that is your IRAT.